The correlator is one technique of implementing a coherent detection scheme. The correlator is based on two operations. The first, multiplication by the pulse shape that was used to transmit the signal. And I'm finishing off the details of establishing pulse, or that pulse shape, as an array coming into the subVI. So multiplication is the first step, and then the second step is integration of that product over the course of the entire bit interval. This correlator is designed for point-by-point style processing within a for loop, and we find the integrator right there. So this style of integrator actually is intended that you apply a single point to it, execute the subVI, and then repeated execution of the subVI will then accumulate values until it's properly or until it's reset by activating its initialized input. So you can pay attention to the various terminals that exist on this. Looking for the reset. There we go. That resets the internal state of the integrator at the beginning of our bit interval. You can specify the value that it ought to be reset to, which in this case is 0. The reciprocal of the sampling frequency then is the sampling interval that the integrator needs. And we're making good progress. Our signal then needs to be multiplied by the pulse shape. Now the pulse is an array, and essentially what we need to be able to do is step through that array so that way we're properly aligning the pulse with the signal associated with that bit interval. So we need to grab one sample at a time from pulse, and we can do that with index array. And the indexing then is based on where the bit interval starts. So we need to be able to reset the index into our pulse array back to 0 at the beginning of the bit interval. See a coercion dot there, and I try to avoid those when possible. So we'll change that to the integer data type. That looks good. So the data selector then picks either 0 at the beginning of the interval, or it picks the previous value. That's being accomplished by this feedback path. We add 1, and that forms our next indexed into the pulse shape. So we see that the feedback node is automatically being inserted into that feedback path, which is good. I didn't like the way it was coming out so convoluted, so let's try that a different way. Turns out that depending on how you clicked on when you're wiring, okay, there's a second way, and also the order in which you wire things together has an influence on how the feedback node gets placed. Let's try a third method here. All right, that looks a lot better. So now we have a structure that on each call we retrieve the next value in our pulse shape, and that can then be applied to the other input of the multiplier. And I think at this point, you're in good shape to continue finishing off this subVI.